So we are on the Vyges website. Every new IP begins the same way, not with a blank repo, but with a structured metadata. I will click build IP here and let's move on. So with this, I'm going to select my organization. And today, what we are going to do is that we are going to build a small block from the Lyra Codec um, that Google has produced. I think they use it internally. It's actually a neural audio codec. And they also have a software implementation of the same, and they have a GitHub repo. So we will kind of use that for our test cases and so on and so forth. Okay, so here we will Lyra VQDQ and then and we will actually build a chiplet IP here just for the sake of fun. So VQDQ um, and we'll make this public, create repo. So right out of the box, what you see is that a repo that has metadata, specification templates, RTL stubs. Okay, you can actually look at this, and the entire test bench structure, CI/CD configuration, and everything that you need to build a reusable IP block. So what we will do here is we will copy this. We will go here. This is my local machine, and I'm going to just clone it, and I'm going to okay. So one of the cool things that I have done is I have basically prepared for this demo a small piece of information as to what I should give to cursor in order to generate everything. This is all I provide. Basically, I have a pointer to that spec, to that codec, and I'm basically saying we have Vyges convention, build a vector quantizer and a dequantizer, and as a standalone digital IP block. Okay. With that said, let's copy this, open up cursor, go full screen. So when I open up cursor, I can use this IDE, but the magic here is that we are going to be using Vyges conventions. The AI copilots already understand the project structure, and I don't need to train it. It knows as to how to fill things and everything. So that's it. Let's provide this information, and it's going to start doing its thing. So instead of boilerplate work, I get architecture docs, SystemVerilog, RTL, test benches, all aligned with Vyges metadata conventions. As you can see, it is actually creating the Vyges metadata, which we will take a look at it very shortly. By the way, no LLM has been trained for this. I'm just using whatever cursor provides. If you're using VS Code, you probably are using Claude, Sonnet, uh, whatever Microsoft provides, or even OpenAI for that matter. It doesn't really matter. The smarts are actually built into the context that we have actually incorporated into this. So this is basically the metadata file, and it's basically a single JSON file that drives everything. It has categories, it has branding information, uh, it has parameters, interfaces, chiplet packaging flows, and that kind of stuff. As you can see, you have test benches, source files that are there that need to be included, and that kind of stuff. This gets updated as more and more code gets incorporated into the system. So this constantly gets updated. And we have chosen the Apache 2 license out here, but you can change it at any point in time. So, and as you can see, you have all the interfaces, and you have the clocks, okay, everything, the parameters, and they're all coded with all the right kind of naming conventions, and how to do all of these things. So it takes into account all of that stuff. So I'll just accept this. Okay, and then I'll go to the next file. So what it is doing here is that it's actually building the architecture specification, and it's basically also wrapping up, it's actually providing a structure as to how it is going to go attack the problem in terms of how the modules are going to be built and that kind of stuff. And here is basically all the diagrams, architecture diagrams, and the signals, control status, operational modes, and the whole 9 yards. If you don't like something, or if you have forgotten to spell out, or you want something to change, this is basically, once it's done, you can say, hey, I don't like this and I want to change this, and it'll actually do all of that stuff. Design specification. This is basically the data flow architecture. So one of the things that you might actually see is that the naming conventions out here. So it's basically saying Lyra VQDQ. Basically, it's the module name, a block name, module name, and that's the convention that we have kind of followed with everything. So that when you actually bring in more and more different IPs and that kind of stuff, they don't clash. Everything is in order. So that those kinds of conventions are automatically programmed into the system. So it has completed um, the first pass at all of these things. It's done the um, IP block implementation. It's created all the reference tests, and it has linked it to the open source test vectors, that because we are using the Google's reference implementation, so it is directly hooked into that. It has used that, and let's make sure that it has, you can see it's the design type is chiplet. And the other thing is that it has chiplet interface, bidirectional, and here it picked up UCIe because I didn't tell it to do anything, I mean, specific. So it built the entire chiplet information. So all the wrappers are automatically generated. So it's chiplet ready by construction. Uh, One of the other things that we have, is that which you can experiment once you start build. You can actually test it with if you have all the things set up, but you can actually generate the reports and everything. We do have test harness reports and that kind of stuff that you can actually generate with this. So there are scripts here which are provided, and you can actually do all the code KPIs and comprehensive test report generation and that kind of stuff. These are kind of important. The other thing is that we can also tell the IDE to actually fix the GitHub action, and it'll actually do the whole thing, and it'll customize it for this. So with that said, ah, so let's say that you have all of these things working. Okay, what next is the question. So let's go back here. We go and say, hey, we want to publish this IP or we want to sell this IP or whatever it is. And you can actually come here and this is basically the IP catalog. You can actually do a direct review and you can say pick an IP category and that kind of stuff. And you can go and see if there are any things out there. Or I mean, I have because I have only a few of them out here right now. You can pick any of these things and we would let's assume that we had the chiplet. You can go look at the repo or you can actually look at the test report. To do that, let's look at this one for example. So you would have a repo, you would have a test report like this, which are actually automatically dynamically generated as a result of this. So you can get like gate counts and so on and so forth, the die sizes and everything. There's a bug in this, so that gate count is not being shown properly, but the constructs are there for you to actually play around and make sure that things are actually getting done. And this one has an FPGA implementation and that kind of stuff. And the other thing is that you can actually look at the waveforms too. This is kind of broken, but I think you get the idea. We have, I think, in one of the other things we do have waveforms that are directly, like for example, if you go look here, and you can actually see synthesis reports and that kind of stuff right here. I think this is one. Let's see. So you would actually have a waveform report, something like this, and you can actually see um, right here. You can basically go here, and so you can play around with it. This is a full-fledged IDE on the cloud, so you can play around with this. So that is what you get with the catalog, and you can actually sell. We do have a store button which is going to get activated some point in time, but that's basically what we have as of today. Uh, so that I mean, we are also going to be providing all the signing services and everything, so that you can actually license your IP and that kind of stuff. So that's the whole part of it. I think the other thing to show out here is basically the Ybox Lite. What you get, you can actually start here for free. And let's say that you want to start a new code space. Basically, it is the IDE in the cloud, and it comes completely built in. And this is actually a brand new instance that I have just started. And what really happens is that you can actually it takes a small amount of time, just like we're spinning up a VM and that kind of stuff at the back end. And this is all on GitHub. So for if your repository is public, GitHub provides you with free credits for a small period of time. So you can look at the pricing information and that kind of stuff. But you get the thing, and this is actually built in with all the relevant tools like Verilator and that kind of stuff, and with open source tools like Yosis, so that you can actually build something, you can test something. So all of these things are actually available. So that's the beauty of this. This is basically VS Code or in the cloud. And by the way, this also has built-in Copilot, so you can actually use AI IDE in terms of code generation and that kind of stuff. So that is what you get with this.